Okay, so we are going to be done this unit on Monday, right? So we're just going to be doing 2.7, 2.8, Monday, Tuesday reviews. Thursday is going to be your unit test, right? Now, these are all called counting problems, not because you're counting 1 to 20 or whatever. You are trying to figure out how many ways, okay? And then next unit, we're going to find probability. How many ways is successful over the total number of ways, right? So very foundational stuff. Now, if you look at this investigation, very much like the quiz, do you see how A is very different than B? Okay? What is A specifically talking about? What are they trying to grasp at? Okay, sorry? Okay, A would be what? Perm or a com? Okay, are there specific positions? Okay, so first, second, and third. So when you see that, you're going to write down first, second, and third. Now, how many ways can you get first? We have 5 people. So 5 people can get first, then 4, and then 3. Or 5, pick 3. So there's 60 different ways. So when you see these positions, order matters. And if you're like, well, I don't see how order matters, just ask. Well, is it different getting first and second? Ask any Olympic athlete, right? Is gold the same thing as silver? Right? And this is the absolute truth. If you win silver in hockey in Canada, okay, and I've heard this right from the actual, like I got to talk to Haley Wickenheiser a week after they won the gold medal last Olympics. Who's that? She's captain of the women's hockey team. Yeah. And 2 years, was it? Yeah, the Olympics before they won silver. And she said that that's something you just put in a drawer and you forget about. Winning silver in hockey for Canada is not, that's a disgrace for them. It really, truly is. I'm not saying that as a fan. For them, it's a disgrace, right? As the U.S. and Canada, whoever gets gold, that's the winner. And whoever doesn't get gold is a loser. That's just what it is. That's the truth, right? That's right from their lips, not me going, oh yeah, if you don't get gold, it's nothing. So I think they would argue that gold and silver are very, very different, right? Getting a gold is very different than a bronze or a, now, I could be honest, if I won a silver medal in the Olympics, I wouldn't be putting it in a drawer, okay? Probably be wearing it every day. Now, how many ways can 5 swimmers qualify for a final race if the top 3 finishers qualify? It doesn't matter if you came in third. So you get to go on, right? That's all that matters. I get to go on. And yeah, you can if someone said to me, if I came in third, and they're like, yeah, you came in third, I'm like, you know what, doesn't matter, I'm going on. Right? So that is 5, choose 3. Also can be written like this, right? Now, does anybody remember, I want to see if anybody remembers, I'll be impressed, what this is called? When I do like this. When you draw 3 lines and you go 5 times 4 times, this actually has a name. Something counting principle. Fundamental counting principle. That is the same thing as a permutation. You can't use the fundamental counting principle for comms. Okay? This is the way you're going to do it. So you get 5C3 and you get 10. And yes, you will always get a smaller number for combinations because, you know what, order doesn't matter. First, second, third, that's the same thing as third, like third, 2, 1. Doesn't matter, I don't care what order. Who's the top 3? You're like, I'm the top 3. Okay, over here. Right? And you got, you know, those people can sit there and talk about, oh, I came in before you. Well, I don't really care. I'm going on. Okay? Now, we talked about if there's things to remember, look for conditions. Okay? That's huge. We'll talk about that more today. The second thing, if you have a repetition of R objects, divide by R factorial, right? We did that on yesterday's quiz. If a problem involves multiple tasks that are connected by the word and, the fundamental counting principle can be applied, and a multiple, and you multiply, okay? So you just multiply the number of ways each task to occur. Now, and we talked about this a bit yesterday, if a problem involves multiple tasks that are connected by the word or, we want to add. Okay, we want to add the number of ways. So you really want to be, like, of course I want you on my test, and I want you the diploma, I want you circling ors, I want you circling ands, because I need you to have a definite plan when you do these. And I was even talking about with another math teacher, because for 99% of math teachers, this is the most difficult of all to even teach. And if anything will help you the most on that diploma, it's you going and writing this test when you're really well rested and you're thinking clear. Okay? So that's why you're not cramming for this test. The night before this test should be your most relaxed. Okay? You might be able to be reading a few study sheets over every so often or whatever, but you know, you got to be on your game, and this is the biggest. Last unit, this one, and the next one are the 3 units that you really got to be thinking, whoa, okay, so, okay, we got an and here, order matters, okay, and then there's an or scenario. Okay, I know what to do now. So let's just look through these and just see how we would do these, okay? Now choose 3 toppings for a pizza from 25 different possibilities. Now, the question, is it a perm or is it a com? And they may be that simple. A question, a multiple choice question, could be which of the following is a permutation? And they'll give 3 scenarios, and you got to pick the one. Okay, so when I'm reading over that diploma while you're doing it in the gym, because that's the only time I'm allowed to do it, is the exact time you're doing it. I do not get to see it a minute before, and I only get it till you guys are out of there. Right? So I'm looking through these and I'm like, okay, they better be getting this one. Okay, I hope they knew this one. So how are we going to know by looking at A if it should be a perm or a com? It will not say that sometimes though. It will not come right out and say order matters or order doesn't matter. Yes? Okay, awesome. You can't have cheese, cheese, cheese. That's the first thing. And that will help you with both of these, right? So repetitions are not in there. Okay, so you don't have to divide by repetitions. Now, I want you to think about when you choose 3 toppings and you order, have you ever been conscious about making sure you ask them in the right order? No. Okay? They will do it the way they're going to do it. So when you're just choosing 3 toppings, that order shouldn't matter. Okay? So then you would go 25C3. Okay? If you have an argument, I'm happy to hear it.
No, I mean, yeah, I just realized 25 choose 3, not 25 pick 3.
Right. And we're going to say Order does not matter. Okay, now some of these right from the beginning you're like, oh, okay, that makes sense now, but I might not have got that if it was a test. Well, the whole trick is doing enough of these so then you kind of will remember, oh yeah, I remember doing this one in class. And if you can remember doing it in class, then you're going to have a better chance of it. Okay, B, perm or com, and Y. Okay. Okay, I've heard com and perm. You're saying com? Okay, your reasoning for com.
It doesn't say they have to be picked in a specific order.
It's assuming that these are all different, right? Yes?
Like, CEO president and vice president are very, very different things, like they're different positions.
Yeah, if I got chose to be president or chose to be CEO, those are different,
Yeah.
right? Those are highly unique, right? So we're seeing specific positions. Order matters, okay? So when you see specific, defined positions, order matters, we're going to go 20 P3. Okay, determine the number of outcomes when rolling 3 dice, 1 red, 1 blue, and 1 white.
How many sides are on the dice?
We're going to assume 6. Okay, but they will be very good at that. So we would say 6-sided. Okay, and this, if this was a diploma question, it would definitely say 6-sided. So the number of outcomes possible when we got 3 6-sided dice, 1 red, 1 blue, and 1 white. Perm or com? Now, do you see for B, if you had 3 spots, so you have CEO, if you have 20 there, how many people do you have for the next? 19 and then 18. Now when I roll the first dice, how many choices are there? The second one? Do you see how this is not really a perm or a com? Now this is called fundamental counting principle. But, so I don't want you to think that fundamental counting principle always means perm. If you count down, it will be a perm. So if you use fundamental going 7, 6, 5, that's a permutation. But if you're going 7, 7, 7, right, that would be just fundamental counting principle. Okay? So sometimes, because this is fundamental counting principle as well, plus a perm. To be both, you need to be counting down. Next one. Determine the number of ways 5 children from a group of 11 can start in a game of pickup basketball. Combination? Yeah, so order doesn't matter. So how would you solve this? 11C5. Now if there was specific positions, then it would be 11 pick 5. Does that make sense? Okay, so if you just, because when you play pickup basketball, it's always lame when someone says, I'm going to be point guard. And you're like, okay, man, like we're just playing basketball here. I don't know if you need to, right? So that's implying the pickup was implying that, oops, order doesn't matter. What am I doing here? Okay. So now this is a huge one. Okay? Now I'm going to show you a way to do these. There's a lot of different ways, and I've been doing these long enough that I have found the one that students seem to really understand. So if you think this one's complicated, there's way more complicated ways to do these. But I want you to kind of listen to the scenario first, because it's a complicated scenario. A piano teacher and her students are having a group photograph taken. There are 3 boys. So we have, oh, why is this pen not working? I have 3 boys, and I have 5 girls. The photographer wants the boys to sit together and the girls to sit together for one of the poses. How many ways can students and teachers sit in a row of 9 chairs for this pose? Okay, so this one isn't as clear-cut as... so we have 3 boys, 5 girls, and 1 teacher. No. Now, this is how you have girl, 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 5 girls. You have 3 boys, and you have a teacher. Now, let me help you understand what's going on here. Now, first of all, the girls must stay together, but they can switch around within here. These boys must stay together. Hold on. These boys must stay together, but they can go and switch their orders within here. The teacher just won, so obviously not going to happen there. But not only that, we could have the 3 boys first, then the 5 girls, then the teacher. We could have the teacher, the 5 girls, the 3 boys. We could have the teacher in the middle. We haven't even done that. So, first of all, I put boxes around them because these have to stay together. Now, those are like 3 different things now. 3 entities. They're 3 groups. How many ways can you change 3 groups? 6 ways. 3 factorial. So just to move the 3 groups, because this can go here and here, right? This can go there and there. So just the 3 groups, just to arrange them would be 3 factorial. Does that make sense for the 3 groups? How you could be, then do within each group. How many ways? So I go times, how many ways can you mess with that group? Just in the group, how many ways can you mess it? 5 factorial. In this group, 3 factorial, and in this group would be 1 factorial. I'm just putting that to be consistent. So it's number of groups, and then within each group. And as we go along on the unit, you'll see we'll have other ones where maybe it'll just be one group. Okay? So an example like this, where say, anyway, if you multiply this all together, you get 4,320. But if you had 4 boys and 7 adults, how many ways could you arrange if the 4 boys must be together? This is more common. If the 4 boys must be together. So you have the 4 boys. Okay, Tan, you really got to be listening to this because you're distracting people back there. You're distracting me. So you have the 4 boys, and then you have the 1, 2, 3, 4, 5, 6, 7 adults, right? Now, do the adults have to stay together? Doesn't say that. So the boys could go here, here, here. Do you see that? So how many groups do we have? Or how many things do we have to be mixing around? No. These are considered how many? This is 1. So you do your 8 factorial first. For the 8, see, we had 7 adults and the 1 group. This is 1 group, isn't it? So it's considered like one thing. And then how many ways can you do the 4 boys? 4 factorial. So that's how you would find the answer to that. Because this is your 7 adults here. It's times. Okay? So this is the more common one that I've seen a lot. So you can arrange the 4 boys, but they stay together, how they can be arranged with the other things, and then how many ways can you arrange the 4 boys. So it's number of groups, which is 8. Now, 1 adult's considered like a thing or a group. Okay? So that's how you would do the 4 boys with 7 adults if the 4 boys must be together. How many different pictures could you take? Okay, and this would definitely be a higher end question on the diploma, but I sure like when my students get those, as you can obviously imagine. Okay, next one. Now, combination problems are common in computer science. Suppose there's a set of 10 different data items represented by A, B, C, D, E, F, G, all the way to H to be placed into 4 different memory cells in a computer. Only 3 data items are to be placed in the first cell, 4 data items in the second cell, 2 data items in the third cell, and 1 data item in the last cell. How many ways can the 10 data items be placed in the 4 memory cells? Now, admittedly, this one, if they didn't start off with this, I would be assuming that you put memory in a different spot, it's going to like screw up your computer, right? But they said it's a combination. So, okay, I'm good with that, I guess. So it says to be placed in 4 different memory cells. 1, 2, 3, 4. Now, only 3 are to be placed in the first cell. So how could I choose them? 10, choose 3. So out of those 10, I guess they're all identical, you know, but in that cell, I'm going to put 3 of them. Okay, so that's 3 items. In the next, I have 4 items. The next one says 2 items. and 1 item. Okay, so how many ways now, and we're going to go, because this is an or, this is and. So I have 3 items in the first one and 4 items, not or 4, because I got to use them all up, right? So now, how do I choose the next 4 items? Okay, that's awesome. See, I don't have 10 anymore, do I? Because 3 are used. So I got 10 choose 3, and now I have the 7 left. I can choose 4 of those. How many different ways can I do that? Okay, and now for the 2 items, I would have 3 choose 2 and 1 C1. And you would have to put those in your calculator. That's pretty arduous getting that in, right? 10 math probability C 3 times 7 math probability C, right? You got to do all that, and you'll get 12,600 ways. Okay, and I just want to add example 4 here. How many, so this is a tricky one too. How many 5-card hands can be made with at most 2 red cards? We did at least yesterday. Today we're doing at most. Can be at most. Okay, so who can tell me what this means? Give me a hand that would have at most 2 red cards. Okay, so at most 2 red cards would be, well, like what would 2 red cards be? So that's 2 red and how many black? 3 black. So this is that you can have that scenario, or what would be another scenario? 1 red, 4 black, or 0 red, 5 black. Okay, so 2 red. How can you, let's do these now. How do you choose 2 red? 26 choose 2 and 3 black. 20. Okay, now because we're doing an or, it's like you get to put all those cards back in. Okay? So then you could see this would be 26, choose 1, 26, choose 4. Or 26, choose 0, which is 1, turns out to be 1, and times 26, choose 5. Okay, that would be 1,299,480. Okay, so we're doing page 140, or no, so not 145, page 45. Numbers 1 to 6 and 8 to 10.